Welcome to the online edition of our Code and Tell.
We're 100% online for now.
So grab some snacks, relax, and get ready for another Junior Dev Code and Tell.
If you've got any questions,
head on over to slido.com.
There's a link at the bottom of your screen now.
We'll do a quick Q&A at the end of the presentation with the questions you asked, so please keep them coming.
Coming to you live, here's our first presenter.
Hello everybody, my name is Patrick, and tonight I'm going to be talking about going serverless on AWS. So whether you are a seasoned cloud professional or someone who's completely new to the cloud and doesn't even know what serverless is, there's going to be something in this talk for everybody. So let's get started. Firstly, a little bit about me. So as I said before, my name is Patrick, and I'm a full stack developer. Very familiar with React, Node, TypeScript, and love GraphQL as well. And I also have a really big focus on working with the cloud, especially AWS, and also the DevOps side of things, so deploying applications on AWS and everything that involves. So in my time working as a full stack dev, I've got 4 AWS certifications, and I'm currently working as a developer for a startup in the design tech space. So we're basically building a briefing tool for studios and design studios and their clients to send briefs to each other, pretty much just trying to get rid of the very lengthy email chains that come with that kind of exchange. And in my spare time, I really love getting out and about and four-wheel driving, camping. But when I'm more at home, I also really like playing guitar and also piano. So quite like music, quite like the outdoors, and full stack developer, that's pretty much me. If you want to get in touch with me, I don't really use social media all that much, but there is one social media that I do use quite a bit, which is LinkedIn. So if you'd like to connect there, just head over to pat.vc/connect, and that'll take you over to my LinkedIn page. And I'd love to hear from anyone really who's interested in this stuff and just enjoy having conversations about it. Okay, so let's get started with the content of the talk. I really enjoy starting everything off with a quote because it provides some context. And I think this is a really, really great quote about serverless. It's by Jeff Bezos. So he's the CEO of Amazon, and until very recently, he was the richest man in the world. And this comes from a time when Jeff Bezos had just started Amazon, and the whole idea of e-commerce was something that people weren't really so sure about, whether it was going to work or not. You know, you had these big retailers, and then Amazon was trying to take them on in the online space. And, you know, now Amazon is one of the largest companies in the world. So obviously it worked out quite well for them, but at the time it was a little bit uncertain. And this is from Jeff Bezos. Around that time in the early 2000s, he said, "It's not an experiment if you know it's going to work." And I really like this quote because it summarizes not only Amazon, but a lot of the things that Amazon does. So little known to a lot of people outside of tech, Amazon also owns Amazon Web Services, which powers roughly a third of the internet. And that's really the focus of what we're going to talk about today, but also specifically going to look at the serverless side of that. And serverless is kind of considered by many to be a bit of a funny experiment that we're going through at the moment. It's only really been around for the past 5 years or so, and it's quite a new concept and quite different to the way things are currently done. So applying this quote to that, serverless is kind of an experiment, but Amazon and a lot of the other people who are really backing this horse think it's going to work quite well and going to change a lot about the industry. So that's why I wanted to talk about it tonight, give you a bit of an overview. And if you already know what serverless is, you might pick up a thing or two that you weren't so sure about. So we're going to start with some history. Where did this all begin? Then we're going to look at where serverless comes into the picture. So what can we actually do with serverless? And finally, we'll have some demos and think about some considerations of when serverless may or may not be exactly what we want, but sometimes there's a lot of cases where it can do quite a bit and save us some time, save us some headaches that we would traditionally get with other ways of doing things. So let's start with the history. Where did serverless come from? And more importantly, where did cloud come from? So if we look way back, maybe not so far back really, because we could begin the history of computing about 170 years ago when people were first thinking about how computers could possibly exist. This is before really even electricity became widespread, in the 1850s or so. But at that time, there was not really much to actually build computers with. So if we look forward to I'd say sort of the real beginning of the computing industry was around the 60s, when we had transistors that were actually good enough to build complex machines that were kind of just, at the time, just glorified calculators. So pretty much anything you can do with just a little pocket calculator today is what you'd be able to do with one of these huge machines that takes up almost the whole room and would have cost tens of thousands of dollars. So we've obviously come a really long way, but this is kind of where it began. It was a tool for big companies to get business critical calculations done quicker. So this could be an accounting firm or potentially some kind of scientific setting where they need to do lots of complicated calculations and they need to do them quickly. If we fast forward about 40 years from there, we get to the early 2000s and things have changed a lot. We're starting to see really the meteoric rise of the internet, and alongside that, really before that, we've had the rise of desktop and personal computing. So this kind of Windows was at the forefront of this in the 90s and in the 2000s, where you've got PCs are now being used by families, businesses, schools, and really everybody, whereas previously they were just a very specialty tool for certain businesses. You can see here as well, by 2005, we had 2/3 of American adults were using the internet in some capacity. These days, it's up to about 90%. So there's still a few people who don't really use the internet, but it's quite a bit more than it was then. But you can still see the very strong beginnings of a powerful trend. So the question becomes, if we've got all these sites and all these programs people are using, like the early days of MySpace, Wikipedia, Google, MSN, and sites like that. So this is even before Facebook and Twitter came along. The question becomes, how do we power these sites so that millions of people can actually access them? And it sounds like maybe it's not really that hard of a task, but it really, really is a big, big problem when you've got millions of people who want to access a site, and you need to power that so that everybody can access it at the same time. And you need to be able to scale to demand, and there's a whole bunch of different issues that go into that. And the answer at the time was, well, let's build data centers. Let's just get a whole bunch of servers, which is just really just computers, and put them in a single location where we can serve that. And this works all right if you're a really big company. So if you're Google or MSN, and even at the time, Google and Microsoft were smaller really than they have become since then. But they were big enough to be able to afford data centers for sure. And so that's been okay for them. But if you're a startup, then you potentially don't have the capital, you don't have the money to be able to afford your own data center. And there's some other issues around it, such as scalability is a big one. So as we're about to see when we start talking about the cloud, some startups in the past 10 to 15 years have really benefited from the ability to scale well, which is just a lot harder with data centers. If you've got to buy all of the computing resources that you actually need, let's say your Instagram scaled 1,000 times, as in they got 1,000 times bigger within the space of just 6 months. So that would require a lot of extra servers. Whereas with the cloud, they were able to do that a lot more easily. Then the third one, and this is really, I'd say probably almost the most important, is that if you're a company that's focusing on some specific thing, then you don't want to be focused on also maintaining a data center at the same time. And so the cloud makes it a bit easier. You still need to know how to use the cloud. You need to have people in your company who know how to do that. But it's a lot easier to sort of train that than it is to train all of the complicated things that go into maintaining as well, and setting up a complicated data center for allowing people to access your system. So here comes AWS. I like to say this is actual footage of the Amazon headquarters in around 2006 was when the first AWS services were released to the public. And there's actually a rumor that the reason that they started offering these services is because they had excess capacity in their own data centers. I think it's kind of a funny story, but it's not actually true. They sort of saw this cloud thing as something that was going to be big, and they really wanted to cash in on it. And they were pretty much the first major, large, usable, and well-featured system for allowing people to basically do what they could do with the data center, but without a data center. So instead of having to buy these computers for yourself, you just rent them, and you rent them on a really, really flexible basis. So you can, within minutes, you can go from having 5 servers running to 500 servers running, and then back down to 10 if you need it to be. So you have really great control over that, and there's a lot of other benefits that come with it as well. So here's really the 3 main draws of using the cloud. The first one is that you only need to pay for what you're using at the time. So if you go and spend hundreds of thousands of dollars buying this big data center to actually set up your servers, well, you own these computers, which is great in a sense, but it also means that you need to pay for the electricity, you need to pay for them when they're idle, and you've also spent all this money that you may not actually be using all of the capacity that you've bought. So with the cloud, you just say, well, what do I need at this particular moment in time? And that's what you pay for. As a result of that, you can scale pretty much however you like. You can say, I want to go from nobody is on this application right now, let's say it's midnight or something like that, and we're only serving one region, then you don't need any servers running, so it's fine. You just pay for the very few servers you have. And then during the day, you might have more customers, and so you might need to pay for more. But we're talking about servers here, but there's a lot of other really cool things you can do with AWS that sort of help you go beyond just thinking about the servers and thinking about what you actually want to do with the servers. So a really good example is a service called S3, which is Simple Storage Service. And it's kind of like Dropbox, except it's completely programmable. So you can build applications where you can put files in there, and you don't need to worry about how these files are being hosted or where they're stored, or really a lot of things about how accessible they are. You just need to worry about what do you want to store and what sort of permissions do you want to have around that, and things like that. So it's much more specific to your application. So it makes it a lot quicker and a lot easier to build some complex applications. There's another really cool abstraction called Lambda, which is AWS's version of serverless, which is what we're going to talk about today. And that is, well, the focus of the rest of this slideshow. So let's start thinking about serverless. But before that, let's talk about who actually uses AWS. So you can see here a list of several companies, and I've kind of split them into 2 categories. The first one is companies that either were or are notable startups. So Netflix, SoundCloud, Dropbox, Reddit, Twitter, Pinterest. These are all companies that have kind of grown off the back of AWS. So they started using AWS when they just needed a few resources, and then they built up to using a lot more when they needed it. So obviously Netflix now, for example, has hundreds of millions of customers watching video, so they need a lot of server capacity. But when they first started, they didn't need as much. And you can see that AWS has also been adapted been adopted by a variety of larger organizations that have existed for a really, really long time, such as the US Department of Defense has a lot of their workloads run on AWS. Some banks are moving towards it. Some banks are a little bit hesitant too, but one of the ones in Australia that's doing a really good job of moving over to it is NAB. And then another company that uses AWS a lot, and I believe actually is AWS's number one highest paying customer, is Apple. So iCloud and all of that surrounding infrastructure lives on AWS as well. So what is serverless, and why would we use serverless? I've just been talking about servers this whole time. We can rent servers, we can do this with servers, but we're going to talk about serverless, which basically takes the idea of servers to the next level. Because what do you want to do with a server? You want to run some code on it. You want to have it achieve something for your business. And AWS has tons and tons of servers, but people don't really care about the servers. They just care about getting things done with those servers. So because they have so much infrastructure, they can say, well, let's just make people pay for what they actually want to get done. So instead of having to deploy an entire server and set up everything about that server, with serverless, I'm saying the word server so many times. With serverless, you don't need to estimate how many servers you're going to need, and you can basically just pull all the servers that AWS has together and just pay for executing a certain amount of code for a certain amount of time with a certain amount of RAM. That's kind of the appeal of it. And this can actually get really cheap. So AWS Lambda, which is AWS's version of serverless, so other types of clouds, which we'll talk about later, have their own versions. And based off just some napkin calculations I've done here, these are probably correct within an order of magnitude, but don't take them as gospel. Let's say we've got 50,000 page views a day on some kind of application, and we're spending 5 requests for every page view, so we need to make 5 requests to the server for whatever reason. Based off the current pricing of Lambda, it's going to cost us 9 cents a day to host this website, which is really, when you think about it, pretty much nothing. And that's 50,000 page views a day, which is quite a decent amount. You also get 5 million free requests a month. So if you're just using serverless for personal projects, it's basically just going to be free. I don't think I've ever paid. I've hosted a lot of little projects on Lambda, but I don't ever think I've ever paid a Lambda bill. So we're going to do a little bit of a demo of how that might work. So this is really just going to be something that I'm just going to show you some code, and then I'll run through every single line. It's quite a small application, and then show you what it looks like when it's deployed. If you want to follow along, it's a little bit tricky because you would need an AWS account. So I'm not really counting on that. Basically, if you are interested in this, I recommend you go to my GitHub after, which I'll link, and you can sort of see the code for it and go from there. There's also plenty of tutorials online. So if you just Google, first serverless application or something like that, you're going to get very similar to what we're doing today as a live video demo. So the way that we're going to do it is just writing code like normal. So if you have experience with Node.js, and I was seeing in the chat before, a lot of people here have used Node.js before. So making a web API with Lambda, with serverless, is a lot like using Express. So you feel pretty much right at home with that. And what we're going to do is, instead of deploying this to virtual machines or containers like you would with a normal Express application, we're going to deploy it directly straight onto Lambda. So it actually cuts out a lot of the work, and we don't need to use Docker or anything like that. I'm fairly sure you can use Docker with serverless, but we don't need to. Actually, I don't think I'm completely wrong about that, but we'll think about that, and I might have a talk about that in the Q&A. Thirdly, we're going to use the serverless application framework to handle the deployment, the routing, the logging, and more. So that simplifies a lot of the work for us as well. And then finally, when we want to access the API, we can just make all the requests we like to the API, similar to how you would when it was deployed using any other system. And there's no need to handle the operating system, the load balancing, scaling. A whole lot of these things are just handled for us. Especially with a small application, it saves a lot of effort. As you get larger, you might want to start manually handling some of these things, but by default, serverless has some pretty sensible defaults for that. So let's go into the first demo. This is basically just going to be a hello world application in serverless. So we're going to make an API where we can make a GET request, and it's just going to return hello world. Then we'll take that up a level and we'll just say we're going to pass in a query parameter and it's going to return that query parameter back to us. So hello with our name, for example. So let's have a look. Let's have a look. Okay. So start with, before we go into how we actually deploy this, let's have a look at what the code does. It's very, very simple. You see here, it's only 7 lines. And this is similar to if we wrote with Express something like app.get / and then we pass in a request and a response. If that makes sense to you, great. If that doesn't make sense to you, don't worry about it. And you see here, we're passing out a function called handler. And all handler does is we take an event and a context, and we just, for this example, because it's not really doing anything fancy, we're just returning a status code of 200, meaning that the request was successful, and a body that just says hello world. We're also logging every time we get a request. So these logs will be available to us on the Cloud Console if we wanted to check them. And that's pretty much all there is to the first function. And then we need to actually get this deployed. So this is where things probably look a little bit new to you if you're not experienced with this, but it's really quite straightforward. This is what's called a YAML file. So YAML is quite similar to JSON. It's just designed to be a little bit easier to read. It's just kind of just like keys and values. We've got service is a key, hello world test is a value, for example. So we just give a name to the service. We tell it to use a certain version of the serverless framework. We tell it what provider we're using. So this can be AWS, Azure, GCP, so Google Cloud Platform. There's the 3 main cloud platforms are all supported, plus a few others like IBM Cloud. And then we also have the runtime. So we're going to be using Node 10. You can use Node 12. It's a little bit less stable. I think they may have fixed that, but last time I checked, there was some bugs with it. So I just tend to stick to Node 10 for these. And then for the region, we're going to be telling it, this is basically AWS code for Sydney. So I'll talk about that because it's quite important. Basically, AWS, don't look at this stuff yet, that's for later. AWS has a variety of different regions where you can deploy code and store objects and things like that. If you look to the Asia Pacific, which is the region we're in, Melbourne, you can see here a blue dot. That means we kind of have a region, but not really. The closest actual full one is Sydney. So that's where pretty much all the services are supported. So we're going to be deploying to Sydney. And it's called AP Southeast 2 because AP for Asia Pacific, Southeast. So these two are Southeast. We've got number 1 is Singapore and number 2 is Sydney. So yeah, I tend to generally just deploy everything to AP Southeast 2 unless I want it to be accessible by an international audience, in which case you might put up a Europe server and a US server as well. And that's generally enough to cover everybody. So the Sydney one would be enough for most of Asia as well. And then you can cover Europe with a single region and US with a single region. If you're a really big company, you probably want to have a more complicated system than that, but it's generally acceptable for small projects. So then finally we put in the function that we want. This is kind of like I was explaining before with the Express routing. It's similar to that. Note that this is not Express, it's just similar to Express. So I make that comparison for people who've used it before because then it makes it a bit easier to understand what's going on. We just tell it the name of this function is just the main function. And we tell it the handler, which is going to be the name of the file that we want to handle this. So it's hello-world.js. Instead of putting .js, we put .handler because that is the name of the function we've exported. And then we tell it when do we want this serverless function, this Lambda function, to actually fire. We say on an HTTP request with a path of /, so the root, and when the method is get. So you could use method post, put, delete, whatever you like, and you can change the path. You can even pass in path parameters, so similar to the way you do that with Express. There's a lot of flexibility here. We're just keeping it simple today. So what do we do when we want to deploy this? It's really quite simple. You would need to install the serverless framework, which is just an npm package, and then you just run serverless deploy. I've already done that, so we don't need to do it. It can take a little while, sometimes up to a minute or two, especially for the first deploy, so I don't really want to wait around. But what we can do instead is we can just go serverless info, and that's going to tell about the previous deployment that we had. And this even itself, it's actually got to go off and request to AWS, hey, tell me information about this deployment, so it can take a few seconds. It's going to tell us these 2 endpoints. We're just going to talk about the first one, and then we'll get into the second one in a bit. We go open, and this directs us to our API, which you can see is hosted on Amazon AWS, and it's hello world. So it's telling us hello world. So we just built a very basic, pretty much as simple as it gets, serverless API. So when this runs, we don't need to worry anything about the server that this is running on or really where it's being hosted outside of just the region. And it simplifies a lot of the work. And the other great thing about it is that it can scale really easily. So if we have 100 people making this request at once, it's not going to worry about that. Even a few thousand will probably be okay. When you have a database connecting or something like that, it can get a bit more complicated. But for this simple one, it's more or less infinitely scalable, which is really great. So let's have a look at the second example. So hello world just returns hello world. What if we want something a little bit more fancy where we can pass in somebody's name and it's going to tell us hello and then put their name? Well, we have pretty much the exact same declaration of the function, and then in hello name, we just say, let's get the query. This is kind of similar to when you have Express and you have request and response, you have rec and res. You'd say, request response. In this case, instead, with Lambda, we have event and context, and the event stores information about the query. So we say query string parameters is going to tell us what parameters have been passed into the query string, which you'll see in a second what that looks like. And then we want the name from that, and then we are going to return in the body, hello, and then put their name in. Okay, it's very simple again. So that has been deployed to /name, and we're going to pass a name in. So this parameter called name is just Patrick, and we get hello Patrick. So very simple, and let's just give it another name. It's going to be called Junior Dev, and we get hello Junior Dev. So that's a pretty basic overview of how to build a serverless API. Obviously, there's a lot more that goes into it than that, but that gives you more or less what you need to get started. So let's continue thinking about the serverless ecosystem. So as I was sort of talking about before, there's three main cloud providers. I've been talking about AWS today, but there's also Google Cloud Platform and Microsoft Azure. So AWS is the largest and most widely used, but GCP and Azure are definitely catching up, and they all have different things that they support. So they're all trying to kind of push ahead and do things that the others have done. So across fields like machine learning and blockchain and all these fancy new things that are sort of happening, developments in the industry, they're all trying to compete to get customers based off a feature set. So as a result, you have a huge variety of different things you can do with each of them. And there's really no one best answer for what you're trying to achieve. It really depends on what the project is. I've tended to use AWS, not because it's the best, but just because I decided I wanted to kind of stick with one. So I'm starting to branch out onto GCP and Azure as well, and quite enjoying that. So there's like I said, there's a really big variety of different things you can do. It's a whole world out there when you come to the cloud. And we're also been using Serverless Framework. This is just one of a few different options you could use, but it is one of the most common ways to get started. The real draw of Serverless Framework is if we want to take out AWS and use Azure instead or use GCP instead, it makes it really easy to do that because Serverless Framework's not tied to any one of them. So you don't really get so much vendor lock-in with it. And then you can also use plugins with the Serverless Framework. So TypeScript is one of them. Webpack is another. There's a lot of plugins to achieve very similar things to what you could do with just like a Node application. You can also write applications in other languages as well, so Python and so on. But Serverless Framework itself is Node-based. Finally, you can link to a whole variety of different services using Serverless. So you can link to databases, caches, object storage like S3, containers, virtual networks. There's a whole lot of things you can do. Really, pretty much the sky's the limit. So it's a really exciting space to be in. I'm going to give you a second demo. So we're not going to go through the code for this one, although it is quite similar to what we've already looked at with just the Hello World. This is a little application I made a while ago. Back when there was only about 170 AWS services. I say only 170, but there's actually a lot more than that now. There's over 200. So if you go to howmanyaws.com, actually I believe I already have this open. Yes, here, howmanyaws.com. And if you load this, it's actually going to dynamically go and retrieve and count the number of AWS services. And surprise, surprise, this system is serverless itself. So what's happening is you load this web page. It's a static web page, and the web page goes off and makes a request. uses Lambda behind the scenes to go off, and it pretty much just counts the number of AWS services that are available, and then it returns that value back, and then the web page displays it. So it's a pretty simple application, but I think it's really been quite cool to have built this when there was 170 or something like that. So that was about a year ago, and now they've added another like 30 in that time, mostly around like blockchain and some of the more buzzwordy services. So if we go back to here, let's continue. So what can we do with serverless beyond what I've just showed you? Because I've only really talked about web applications, but there's actually a whole variety of different use cases for it. Firstly, you can use it to build backends and APIs like what I've showed you. You can use it to run GraphQL servers, which is pretty cool. And you can, so just REST endpoints and things like that. There's a cutting edge framework called Next.js, which is a React framework. It's kind of like you've got React is a web framework in itself, and then on top of React, you've got Next.js and a few other things like Gatsby. Next is one of my favorites. I use it all the time, and it basically really simplifies a lot of things like the routing, and also allows you to do a thing called server-side rendering. And when you deploy that, if you deploy it in a certain way, behind the scenes, it will use serverless to power some of that functionality. And then another use case is just to glue different parts of applications together. So you can use Lambda or really Google Cloud Functions or Azure Functions or whatever to connect various things. So if you upload a file to the cloud somehow and then you want to inform a user of that, for example, or go off and do some work on it, like generate a thumbnail, then you can do that with serverless functions. And finally, there's a huge amount of innovation in this space. So people are trying different things like using serverless CI/CD builds, QA, and also things like cron jobs, so scheduling database changes, things like that. Really anything you can think of that has traditionally been done with servers, people have probably tried, if not succeeded, to do it serverlessly. There's a huge amount of things going on with this, and it's a really active space. There's quite a few like serverless meetups and serverless talks and things like that if you're interested in sort of going down this rabbit hole. Okay, it's time for the final demo. So this is a little bit more advanced than the previous ones. Essentially, what we're going to be demonstrating is how we can use what I talked about before with the idea of gluing things together. And we're going to demonstrate an application where you can upload photos, and then you can take those uploaded photos and automatically generate thumbnails from them. This is the first time I've done this. This is actually going to be a live demo where it's kind of a bit interactive. So you'll see what I mean in a second. Here we go. So welcome to the serverless thumbnails generator. You can access it by going to pat.vc/thumbnails. And what this provides is an interface to upload a photo, and it's automatically going to resize that photo into a thumbnail, and then it will sort of synchronize that across everybody who's got this application open. So feel free and upload some memes or something you've got on your computer. Please keep it G-rated, but I'm just going to demonstrate by putting a couple of photos up, and we'll see what people come up with. So I'm going to put this one here. It's just a photo from a Europe trip. We click OK, and it's going to upload. It's finished, and pretty soon we can see this photo, and then we can see the thumbnail of the photo. There we go, it's appeared. Let's try one more. There we go. That's a very good one. Yeah, I do have some credits that I'm not afraid to use. No, I didn't say that. S3 and Lambda are quite cheap, but yes, I may have to shut this thing down if people abuse it. All right, I'll give it a few seconds, and we'll see what people put, and then we'll oh, there's another one. Okay, cool. I'll leave this be for a bit, and then we'll come back and have a look. Okay, so actually, first of all, I just want to explain what's going on with this. So we upload the photo, and what's actually happening is really interesting the way that this works. It's using a paradigm called the valet key. So you've probably never heard of this. It's something that that Microsoft has come up with when they talk about Azure. But what it does is basically, instead of having a constant connection to the server in order to upload the photo, which is normally what would happen, like the client's going to stream that photo up to the server, instead we just make a very short connection to the server, and the server gives us like a key. And then we can use that key to go off and directly upload the photo to a storage service, which in this case we're using S3. And so that's the first part of it. That's the uploading the photo. And then the second thing that happens, okay, someone screenshotted this and you got me. Hello there. Okay, if I can ever scroll through these, we get to the thumbnails. And what's happening is S3 is configured to automatically, whenever you get a new photo that arrives in S3, it's going to go off, run a separate Lambda function that will automatically rescale the photo, generate a thumbnail, and then re-upload that back to the S3 bucket, and so we can see these in the thumbnails. Now, these photos are actually sized the right size. I really like this photo. I had that as my wallpaper for a little while, actually. So these photos are actually sized based off, like, they're a really small file size and they're limited down to about 200 pixels or something like that. So the resize is actually happening on the server. It's not something that's just like, restyling the image or anything like that. It's actually happening on the server. So you can imagine this would be used in something like a social media application or something like that. Okay, I think that's enough serverless thumbnails. We're getting towards the end of the talk now, but there's a couple of things I wanted to talk about. The first one is just some considerations of when serverless might not be the best idea, or things we should be aware of with it. So, like everything, and especially like everything in software engineering, there are trade-offs. And while serverless can really help us to build applications in a way that is it's quicker to get things done, and sometimes you just don't need to worry about scalability and things like that. And it definitely has a lot of benefits. You've also got some problems. The first one is real-time applications. It is possible to build these with serverless, but it takes quite a bit of work. You need to set up like message queues and fancy things like that. So doing it natively with Lambda is a bit of a struggle. So personally, I would just set these up on containers instead. Second one is the price. I know I said previously Lambda can be quite cheap, which you guys are really giving me a run for my money for. But in certain cases, it can cost quite a lot. If you are running, for example, if you have a Lambda that runs for 3 minutes straight, which is, you're allowed to do that. But if you have a Lambda that runs for 3 minutes straight and uses a whole lot of memory, and then you need to run that, several times an hour or something like that, or just keep it running constantly, well, in that case, you might be actually better off renting a server to do it instead. Just because if you're wanting to use the full capacity of a server, then just rent a server and you have less overhead, really, because AWS does slightly charge a little bit more for Lambda if you just think of it per amount of compute. But the real advantage is you don't have to have the server on. So if you're going to have the server on anyway, you may as well just keep a server. The last one is the speed and concurrency. So like many things with serverless, this is getting better, almost to the point where it's not really so much of an issue. But there's a lot of time that has been spent optimizing containers and optimizing like load balancing and things like that. Whereas with serverless, there's sometimes some issues with connecting to databases and connection pooling, things like that. So if you're getting into the more database end of using serverless applications, there can be some pitfalls. So that's the main three considerations. One last thing, I know I've given a lot of links in this presentation to random little things I've made, but this one's called Match the Cloud. It doesn't have anything to do with serverless, as in it's not built with serverless, but what it actually is this little application. If you go to Match the Cloud, it is sort of like a guessing game for AWS. So you can see here. I made this to teach myself Vue.js, by the way. You can see the little logo there. So you have to basically guess which of these icons corresponds to the correct AWS service name, of which, as we have seen, there is like 200. So which one of these IoT analytics? Maybe this one? Okay, I was wrong. It was this one. What about this one? Container registry. I think off memory it's this. Yeah, okay, there we go. And it just goes on ad infinitum. So if you really want to test yourself, I don't think there's anyone in the world except maybe like people who work at AWS who would get all these right. But yeah, you can test yourself with Match the Cloud. Okay, so that's pretty much all the demos for today. And we're going to finish up and then we'll start looking into the QA. So if you want to get in touch with me, like I said at the start of the presentation, you can connect with me on LinkedIn. Just pat.vc/connect will take you over to my LinkedIn page. And then let's have some questions. So I believe there's a Slido link that's going to come up on the talk. So if you want to visit that link and go to the Q&A page and you can start asking some questions. And I'll take on some of the questions that have got a few people wanting to know the answer, and I'll do my best to answer them. So thanks for listening to the talk, and we'll do the Q&A now. All right. Okay, I'm here. Oh, cool. Okay. So here we go, first one. Are you able to tell roughly about the prices when using AWS? It's never really clear how much you'd expect to pay on services like S3, even in the first year. That's a really good question. And I mean, pricing on AWS is its like own like thing you can learn, because there's a quite complicated set of rules around what costs what. So the first things to help out is the AWS budgets gives you a good overview. So if you go to the AWS console, you can sort of get a drill down of that, and it sort of tells you where the costs are coming from and where they could potentially come from. So with S3, for example, your main costs are going to be from the data, the bandwidth, like the throughput. What's the word? The transfers. So you know, if you transfer 5 gigabytes in a month or something like that, you pay on a per gigabyte basis. And then the second cost is obviously actually how much are you storing. So I would sort of run the calculations based off of that, but you sort of eventually get an intuition for, okay, if I'm going to upload this 3 terabyte file to S3, for example, you can expect it's probably going to cost a lot in the storage. And if you're trying to stream it out to a bunch of servers, it's probably not a great idea. There might be better ways to do that. When you said the first year, that's an interesting point, because for those of you who aren't aware, you get a year of a lot of things being really free, essentially, on AWS. It's called the free tier. And I'm not sure if S3 is one of those, but it does make a difference in the pricing. So if you want to, it does kind of lower the barrier to entry. So if you just want to try out AWS or try any cloud platform, it helps to sort of know what the free services offered are. I hope that answers the question somewhat. I know it's quite a complicated topic with a lot of nuance. So, all right, let's have a look at the next question. I'm just going to open up the YouTube live stream as well. I'm only really going to be taking questions from the Slido. So if you are asking questions in the live stream, send them over to the Slido. Yeah, so Firebase, wouldn't it be simpler for Firebase to start with Firebase? Look, I think you're probably onto something there. Personally, Firebase is something I haven't used a whole lot of. But I have talked to a lot of people who have built things off it, and especially if you want to do real-time applications, it seems like a really good option for someone who doesn't want to set up a whole bunch of different things. The other great thing about Firebase is that some of the features are themselves serverless. So if you want to get involved with serverless, that's a good way to do it, honestly. I'm not married to AWS. I think GCP is great, so Firebase is pretty good. I'm just giving you a demonstration of sort of how I got started, and I think it's also really the barrier to entry with serverless framework is not too high. If you were trying to use something like setting up your own CloudFormation templates and AWS serverless application model, and there's a whole bunch of other ways you could do this that would be a lot more complicated. I wouldn't advise. But yeah, serverless framework is good. Firebase is also another great option, and I know a lot of people have got started with that. Okay, next question. About the Hello World function, was that Lambda? If so, how did you manage to access it directly? I thought you need API gateway service to access functions. Yeah, okay, so that's a really, really good question. So you're correct, it is Lambda, and it is also API gateway. And the way that works is in the serverless.yaml, we tell it what we want the functions to do. So we tell it the actual code, and then we also tell it what events. And this is the beauty of serverless framework, and why I love it so much, is it will handle these things for us. So you can see here it says events HTTP. Anytime it's going to see an HTTP event, it goes, okay, well, we need API gateway, which is another AWS service, and it's going to implement that automatically for us. And as someone who has tried to implement an API gateway proxy for a Lambda function manually, I can tell you having it done automatically is amazing. So that has been a real benefit to using serverless framework. Another thing with that as well is you can get a lot more complicated than the ones I've just demonstrated. So the example I showed you where you've got the S3 bucket and it's automatically generating thumbnails of the image, that's all just using serverless framework. So that S3 bucket is set up using serverless framework, and the connection between the S3 bucket and the Lambda function is also using serverless framework. I didn't really want to show the code for that because it can get a bit hairy, but if you want to check that out, just head over. So if you go to the serverless thumbnails generator, down the bottom, you've got a little link. Oh, we've got quite a few photos now. You got a little link to the GitHub, and this will open up the repo where you can see basically whatever's all the code for this, and you can see the serverless framework YAML file for it as well. Okay, cool. So let's continue. Next one. Is it possible to deploy one function to multiple AWS at once? Ooh, that's a great question. And I think, yeah, to be honest, like serverless is something that I have mainly worked on for just personal projects where I don't really care so much about it being available across different regions. So it's not something I've specifically tried. But either that is going to be possible, or you may be able to do it using some sort of, like YAML is really good for sort of templating your configuration, like copying sections. So you might be able to do something like you have one function in one region, another function that's the same but in a different region, and you can sort of dry that code out a bit, like getting rid of some of the repetition. That's probably an option. Otherwise, it may just be natively supported. I'm not completely sure. Yeah, that's a good one. When should we not use the serverless application framework and consider other options? So CloudFormation, SAM, etc. Yeah, good question. So, well, CloudFormation you would use if you have a sort of complicated architecture on AWS that you want to store as code. So for those of you who've heard the term but not really sure what it is, infrastructure as code, CloudFormation is that. There's also a few other things like Terraform, which are similar. So I would use CloudFormation if it was kind of a more complicated system, but you can kind of basically, so there's all kind of connected to each other in interesting ways. So Serverless Application Framework actually uses CloudFormation behind the scenes. So it'll set up the resources you need. And then Serverless Application Model, I haven't looked into it too much, but that's potentially another option. I think it's native to AWS, so you do get the vendor lock-in, but it's potentially something that might integrate a bit better with CloudFormation if you've already got a significant amount of CloudFormation you're using. Okay, we'll do a couple more questions. So what utility did I use to run serverless.yaml? So by that, I'm assuming that you mean what utility sort of like to actually deploy the file, because what this serverless.yaml is it is a framework. Sorry, serverless.yaml is just a config file for the framework. So the framework is going to read that in behind the scenes is what's going on. When I run serverless deploy, it's reading the serverless.yaml file. Yeah, hopefully that answers the question. I'm not completely sure what that meant. Okay, and I think this will probably be the last question. So can you share some examples of real projects you worked on that use serverless and why I chose serverless functions? Yeah, so I actually had so I mentioned previously we were using GraphQL on the serverless backend. So that was a big project I was working on where we had a GraphQL API that was all serverless. We did run into some issues with the scaling of that. So if I was to make a large scale application again, I would probably I would probably use serverless if I was confident it was going to work for some things, but I would avoid it for certain bigger things. But you can sort of get around that in the ways that I mentioned previously. Why would I choose serverless functions? Because I think it's just a lot easier than working with like containerized microservices in some cases, and having to handle all the scaling and the balancing, and there's a huge variety of things that go into that. So it sort of people consider it like the duality of, do you use containers or do you use serverless? And it's just one of the two choices. It's not necessarily the best choice, but for certain projects, it can be something that's good. Personally, my recommendation would be, if you're interested in this, go and learn about serverless and sort of get the paradigms down. That's sort of, this talk is trying to get that across. But it's something that is great for small projects, and it's also great for startups when they're sort of just beginning. If you don't want to, it can actually be quite cheap to sort of run a basic thing when you only have a few customers. If you're just using serverless, because you don't really need to have a whole set of containers running. So that can be a good cost saver. So that would be another advantage. Okay, I think really that's pretty much, it's about all we've got time for today. But thank you everybody for coming along. I've seen a lot of interest in this, so that's really great. I'm sorry if I couldn't answer your question, but hopefully this has given everybody a really great overview of what serverless is, what it can do, what maybe it can't do, and I hope you enjoyed the little demos. So yeah, thanks for coming along, and I'll see everybody at the next Junior Dev.
Hi everyone, in the next few moments I'm going to chat to you about a conference we have coming up and how you can submit a talk for it. I'm Lee, and about 3 years ago I said I'd run PyCon AU in 2020. PyCon AU is Australia's peak Python conference, and my team and I had a lovely plan to bring it right here to my home city of Adelaide, but 2020 had other ideas. So despite all of this, we're doing it anyway on the 4th to the 6th of September. So while much of this conference is my fault, I'm here with our program chair, Benno, who is in charge of selecting the talks that go into it.
Thanks, Lee. So this year we are online, very online, one might say extremely online. In fact, we've even named the conference PyConline AU. That means some opportunities, but definitely a lot of changes. Obviously, everything's online. All the presentations will be via video stream, either live or pre-recorded, which means it'll be a bit different, but we're doing our best to keep the feel of the conference the same.
Yeah, so for lots of people, PyCon AU was their first time public speaking, me included. And we pride ourselves on having a range of voices on a range of topics, so your talk doesn't have to be massively technical or Python-y. If you think it's of interest to the Python community, we're interested in hearing from you.
So in addition to the main conference, we've also got 5 specialist tracks. These are sort of smaller, focused mini conferences. They're the same kind of idea as we've had in previous years, but because we're not limited by the number of rooms we have, we've got more of them. So this year's specialist tracks include DjangoCon AU, which is not just about Django, but anything web-ish. Security and privacy, which is not just about not getting pwned. Data science and analytics, which is about crunching numbers and all that fun. Education, which is about learning and learning about learning. And DevOps, which is about failure and learning from that.
So if you have an idea and you want help turning it into a talk, you can talk to us and we can introduce you to a mentor. Head on over to pycon.org.au/speak and check the details about connecting with a mentor there. And remember, the more submissions we receive, the more difficult it makes Benno's life in a few weeks' time when we're choosing the talks, and the better the conference is. Our call for proposals closes on the 12th of July anywhere on Earth.
So that's midnight on July 12th if you're in the United States minor outlying islands.
Or 9:30 p.m. on the 13th if you're in Adelaide like all of the cool kids.
And don't forget that the conference itself is September 4th to 6th, extremely online. All the information is at our website, which is down there. Yeah. Including all the information on how to propose a talk and all the other stuff about the conference itself.
So I'm looking forward to seeing many of you at PyConline AU this year and hopefully presenting as well. Good night.
Is that good? Did that work?
Thanks for tuning in to Junior Dev Live.
And you can stay up to date on everything Junior Dev on Twitter or on meetup.com.
From the rest of the team, stay safe and enjoy the rest of your week.
Bye!